Hey kids, Flexing Teacher Weber here. What we're going to do next in our next video, in the previous video we had done the surface area of a cube. Now we're going to do the surface area of a rectangular prism, which is very similar to that of a cube. Now, we had already talked about the net of a rectangular prism, and I'll just go back. So here's the net of a rectangular prism, right? It's very much like a cube, but it's made up of rectangles. And in particular, it's going to be rectangles of different sizes, as you'll see. So here's our rectangular prism. The rectangular prism has a length of 10 centimeters, a width of 4 centimeters, and a height of 6 centimeters. And it's made up of 6 rectangles. Now what we're going to do first is we're going to draw the net. Now I like to start with the bottom or the base, and I'm tracing that out right now, if you can see that. The bottom of this rectangular prism has a base of length 10, width 4. So what we're going to do for our net in the middle of our page, we're going to draw a rectangle that is 10 by 4. And we're just estimating the sizes, right? It's not a scale drawing, it's just a sketch. So there's your 10 by 4, and let's call that BO for the bottom. Now, we just drew the bottom. Next thing I'd like to draw, and remember there's many ways to do them, is I'm going to draw this front. I'm going to call it the front rectangle because it's closest to us, and it's going to be connected to the bottom, but it's going to fall forward. Now this front rectangle is a 10 by 6. So it's going to be connected to the bottom and it's going to fall forward. So it's a 10 by 6 rectangle. So I'll make this just a little bit longer, but it's still going to be 10, falls forward, and there's your FR for the front, and we'll call it 10 by 6. So there's your front rectangle of this rectangular prism. Now what I like to do is I like to draw the sides. Here's one side, here's another side, right? And you can see down here, they're connected to the bottom, right? And I'm going to have them fall out sideways. Now, the dimensions of that rectangle, it's a 4 by 6. 4 by 6, and we're going to leave it connected to the bottom. So, right here, we're going to leave it connected to the bottom, and we're going to draw it out 6. And there's your 4 by 6 rectangle. We'll call it SI for a side. And then same thing over here. Same size rectangle. Remember, it's not a scale drawing, so we might not be perfect, and that's okay. Okay, 4 by 6. Call it SI for the side. Okay, so we've got 4 out of the 6 rectangles for this net drawn. Let's take a look at what's next. So we've got the bottom here. Then if you look connected to the bottom, I'm tracing it right now, there's a back, right? There's a back rectangle that's connected down there at the bottom. So here's the back. And I'm going to have this back stay connected to the bottom, but I'm going to have it fall backwards. Now look at what it's going to be the same as. The back has to be the same size as the front. So it's going to be a 10 by 6. So we'll connect the back to the bottom. And the back will be the same size as the front. Oh. Try that again. So it's 10 by 6. We'll call it BA for the back. So now we have 5 of our 6 drawn. Now all we're missing now is the top one. I'm tracing the top rectangle right now. And the top one is going to be the same as the bottom. It's going to be a 10 by 4. So top the same as bottom. It's going to be a 10 by 4. And I'm going to leave that top one, I'm going to leave it connected to the back there. And I'm going to fold it backwards. And I'm going to fold out the top. And there's your 10 by 4. We'll call it TO for the top. And there's your net for this rectangular prism. And it's all labeled with its dimensions. And you can see here, you have, what you really have are 3 different sized rectangles. You have a bottom 10 by 4, that's the same as the top 10 by 4. You have a front 10 by 6, that's the same as the back 10 by 6. And you have 2 sides that are 6 by 4. And that's the net, the 2-dimensional net of this 3-dimensional rectangular prism. Now, to calculate the surface area, we want to calculate the total area on the outside, including the area on the bottom. So let's do our surface area calculation. We're going to have 3 different rectangles, but we're going to have 2 of each. So let's start with maybe our top and our bottom. Doesn't matter how you start, but I'm going to start with top and bottom. TOBO. I'm going to write down my area math equation for a rectangle. Area equals length times width. The length and width of the top and bottom is 10 by 4. So I'm going to substitute in my values. This is just algebra again, right? 10 times 4. The area of one of those rectangles is 40, and we're talking centimeters squared. But remember, that's just for one of them. We have 2 rectangles that are this area, right? This is for one of the top or the bottom, but we have 2 rectangles that are 10 by 4. So we have to take that area for one of them, and since there are 2 that are the same size, we have to double it. So the area of the top and bottom is 80 centimeters squared. Now, let's do our front and back. I'll put FR, BA. We still start with our math equation. Area equals length times width. Area equals, now if we're talking about the front and the back have dimensions of 10 by 6. So to calculate the area of one of those rectangles, you do 10 times 6. Area equals 60 centimeters squared. However, that's just for one of them. Remember, there's a front and a back, and they're both going to be 60 because they're both the exact same size rectangle. So I've got to double my area. I've got to double times 2. Area equals 120 centimeters squared. So I've got my top and bottom, my front and back. Now I need my sides. Put SI for the side. Area equals length times width. Area equals, let's look at the dimensions of my sides. The length is 6, the width is 4, but remember there's 2 of them. So I'm going to calculate the area of one of them. 6 times 4. Area equals 24 centimeters squared. But remember, there's 2 of them. There's 2 sides, right? So this one will be 24 and this one will be 24. So I have to double that area. And I get area equals 48 centimeters squared. So I've got the area for the top and bottom, the area for the front and back, and the area for the sides. Now to get the total area, I'll label that total. I'll just take my 3 areas and add them up. 120, 80, 48. I'll add them up. And my total surface area for this rectangular prism is 248 centimeters squared. When you do these questions, I'd like you to get in the habit of organizing them nicely with labeling what you're calculating. Use the math equations. Use substitution. Don't forget your units of measurement. Show me what you're doing nicely down the page. So today for your assignment, I'm going to get you to do a surface area calculation for a cube and a surface area calculation for a rectangular prism. I hope that helps. That's all for now. Flexing Teacher Weber out.